Om Sri Sairam. Dear children, today's class we are going to learn about chemical properties of carbon. Before that, let us look at the assignments question. Write the structure of pentanone. Yes. What is the functional group present in pentanone? Yes, ketone is the functional group present in pentanone. It is the structure, it is like this. Next, ethanoic acid. What is the functional group present in ethanoic acid, children? Yes, good. That is carboxylic acid, COOH group. Structure is, this is the structure. Ethanoic acid. Yes, good. That is, this is the structure. What is homologous series? Explain with example. You know what are homologous series already. Homologous series is a family of organic compounds with same general formula, similar chemical properties, and the successive members are differing by CH2 units. I gave example of alcohols, even alkanes, it will happen alkynes, alkenes. These are where similar in their general formula, but each successive member is differing by CH2 unit. That is about homologous series. Today's session we are going to learn about chemical properties. First we are going to learn about combustion reaction, second oxidation reaction, third addition reaction, fourth is substitution reaction, and last the properties of ethanoic acid and ethanol. Let us learn what is combustion reaction. For simple definition, what is combustion reaction? Reaction takes place in the presence of oxygen, generally it's called combustion reaction. Reactions carried out by heating organic compound in excess of oxygen or air, means reaction that carried out heating in the presence of oxygen or in excess of oxygen, that is known as combustion reaction. There are exothermic in nature. Why they are exothermic? We learn what is the definition of exothermic in chemical reactions and equations. What is exothermic? As reaction takes place where energy, heat is liberated. Similarly, combustion reaction, large amount of heat is liberated. So they are exothermic in nature. General equation is C plus O2, CO2 plus heat and light. It's a general example for combustion reaction where carbon reacts with oxygen gives rise carbon dioxide, where heat and light. This is a general example for combustion reaction. You have to remember this. Combustion reaction means takes place in the presence of oxygen. That is a key word for combustion reaction. Next, there are two types of combustion reaction. One is complete combustion reaction. Second one is incomplete combustion reaction. Next, what is complete combustion reaction? Very simple. Very important. See here. Methane burns in air or presence of oxygen with a non-luminous flame forming carbon dioxide and water. When methane burns, it forms what? Carbon dioxide and water. But what is the keyword? Non-luminous flame, means it has blue. We'll see that blue. Example, gas stove. When we lit the gas stove, we'll see the blue light. Even Bunsen burger, that is also you'll see Bunsen burner. Second, general example for complete combustion is when methane reacts with oxygen or methane burns in the presence of oxygen gives rise carbon dioxide and water. This picture you will see that this is the light, that blue color light will form. Complete combustion takes place. How we can observe? Just when we see the blue light, we can conclude that it may have complete combustion reaction. Next, complete combustion reaction is indicated by blue flame. This is about complete combustion reaction. Complete combustion reaction you can see in gas stove. When we lit the gas stove, there you will see the blue flame, or even in Bunsen burner. When we'll do some of the practicals, we lit the Bunsen burner, then you will see the blue flame. That indicates that it has completely combustion. Next, what is incomplete combustion? Methane gas burns with an yellow flame forming carbon monoxide. This is very important. Forming carbon monoxide. This is very important. There carbon dioxide. Here it forms carbon monoxide and water. Next, this is the equation for incomplete combustion. Incomplete combustion can also seen in automobiles, where CO is releases due to incomplete combustion. Example, motor vehicles or automobiles. Most of the automobiles releases CO because of their incomplete combustion. This is the flame. Flame always indicated with yellow flame. Yellow flame. This is about incomplete combustion. You have to compare between combustion reaction and incomplete combustion. Combustion reaction, when methane burns in the presence of oxygen, where it forms what? Carbon dioxide and water. Here, in incomplete, it forms carbon monoxide and water molecules. Example, for complete combustion, example, when we lit a gas stove, it's also example. We will give here automobiles. Due to automobiles where CO is released because of their incomplete combustion reaction. This is very important, children. Next, what is oxidation? You know what is oxidation generally, children? Yes, means in first chapter of chemical reactions and equation, we have learnt about oxidation. What is oxidation? Can anybody guess what is oxidation? Yes, very good. Gain of oxygen, loss of hydrogen is generally known as oxidation. What is reduction, children? Can anybody guess? Yes, gain of hydrogen, loss of oxygen is known as reduction. Here, oxidation reaction, carbon compounds can be easily oxidized by combustion reaction. First point, by combustion means carbon compounds always react with oxygen. So first point is you have to know carbon compounds can easily oxidize it by combustion reaction. In addition to complete oxidation, very important. This is very important point. Alcohols are converted into carboxylic acid by acidified K2Cr2O7 potassium dichromate or potassium permanganate. In the presence of potassium permanganate or potassium dichromate, alcohols are oxidized to carboxylic acid. Remember this point, very important. How alcohols are converted into carboxylic acid? You have to write in the presence of catalyst, that is K2Cr2O7 potassium dichromate or potassium permanganate KMnO4. Next, this is the general equation where ethanol is converted into ethanoic acid. How do ethanol is converted into ethanoic acid? Through oxidation reaction. In the presence of KMnO4, it has converted into ethanoic acid. This is very important, children. Please note down the equation. Please note down this equation. Ethanol is converted into ethanoic acid through alkali KMnO4 or acidified K2. It's an alkali KMnO4 or it's an alkali KMnO4 or acidified K2 acidified. Acidified K2Cr2O7. This is very important. They may ask, how do you convert alcohols into carboxylic acid? You have to write this equation. This is about oxidation reaction. Oxidation reaction, you have to remember, alcohols are converted into carboxylic acids by what this alkaline KMnO4 or acidified K2Cr2O7. Next, we are going to learn about addition reaction. Third reaction we are going to learn about addition reaction. Very simple. This is very simple. Unsaturated hydrocarbons are converted into saturated hydrocarbons. This line is very important. Unsaturated hydrocarbons are converted into saturated, means double bond is breaker into single bond, means unsaturated compounds having double or triple bonds are converted into saturated compounds. Saturated means single bond compounds. In the presence of catalyst, very important word. This is very important. In the presence of catalyst, where what is addition reaction? Unsaturated hydrocarbons are converted into saturated hydrocarbons. Next, examples: alkenes, alkynes. Is alkenes or alkynes saturated or unsaturated compounds? Good, they are unsaturated compounds converted into alkanes using hydrogenation of means that is using hydrogenation of vegetable oils with nickel as catalyst. Here nickel as catalyst, they are converted. One example, this is the one more example, general example it is, where see this, what is this compound name? What is this? Ethene is converted into 1,2 dibromo ethane. It is converted into by nickel as catalyst. It is a general equation. Ethene is converted into, in the presence of bromine, it is converted into 1,2 dibromo ethane. Unsaturated compounds are converted into saturated compounds. Let us look at one more example, where very easy example. Unsaturated is converted into saturated compound by nickel as catalyst. Can anybody write this compound? I have shown that there is some mistake. Please write down this. What is the compound form there? Please write down. Yes, good. This is the compound where R is aryl alkyl group. Means, see, here you have to remember, what is addition reaction? Unsaturated hydrocarbons are converted into saturated hydrocarbons. This is the general equation. You have to remember this. Next, this is the example. Please note down, where R is alkyl or aryl group. This is the equation. Please note down this equation. Next, what is hydrogenation? Very important. Very important. Please note down. The process of converting liquid oils into solid saturated fats by passing hydrogen gas in the presence of nickel catalyst. Means they are nothing but, simple definition, they are nothing but converting liquid oils into solid saturated fats using nickel catalyst in the presence of hydrogen gas. Hydrogenation means liquid to solid using what? Catalyst, nickel catalyst in the presence of hydrogen gas. Next, what is catalyst? Children, you have to remember what is catalyst. Catalyst increases the rate reaction without affecting the chemistry of the reaction itself. Means it helps the reaction to occur quickly or fast. It alters the rate of reaction. It helps reaction to form very quickly. Next, this is very important. Vegetables, oils and animal oil. Please remember, vegetables oils have long unsaturated carbon chains. Oil containing unsaturated carbon chains should be used for cooking. Means we always use it unsaturated. That is used for cooking. Unsaturated carbon chains used for cooking. Next, animal fats with saturated carbon chains are harmful to our health. Means unsaturated what? Unsaturated oils are used for cooking, where saturated oils, saturated carbon chains are very harmful to health. You can write the difference between vegetables oil and animal fat. Next type of reaction is substitution. What is this? Substitution. That is a fourth type of reaction. What is substitution? Easy. When a mixture of methane, means CH4, chlorine is exposed to ultraviolet light, or typically in the presence of sunlight, a substitution product, that is monochloromethane, is formed. Monochloromethane is formed, means it has substituted. One element is substituted in the reaction. Example, this is CH4, means these two reactions substitute to form this. What is this? Monochloromethane. In the presence of sunlight. Substitution means these two get substituted to form this product, one HCl. Here HCl. Next, substitution reaction means in the presence of sunlight, a mixture of methane and chlorine reacts to form. What is this compound? Monochloromethane or methyl chloride and hydrochloride, HCl. Second, all hydrogens in methane can be replaced. All hydrogens in the methane can be replaced by chlorine atoms forming. Very important. This we are going to learn now. Dichloromethane, trichloromethane, tetrachloromethane. These reactions now we are going to learn. First reaction, we will write this first. First reaction, please write CH4. When methane reacts with what? Chlorine, it forms UV or sunlight, CH3Cl plus HCl. Now let us do CH3Cl. Reacts with chlorine. Now what is the product? Please write down. What is this? Plus HCl. Dichloroethane. Next, take this compound CH2. These are reacts with sunlight. What is the product? Please write down. Curd, CH, these all are substitution reaction. Take that. Next, write this equation. Complete this. Good. CCl4 plus HCl. This is the examples for substitution reaction. Once again, I'll repeat. Methane reacts in the presence of chlorine. In the presence of what? Sunlight, it forms what? methyl chloride or 1-chloromethane, where HCl gas is liberated. Similarly, when CH3Cl, that is methyl chloride, reacts with what? Again chlorine, it forms dichloromethane and HCl is liberated. When dichloromethane reacts with again what? Cl2, this is a substitution reaction. It forms trichloromethane plus HCl. Next, trichloromethane reacts with Cl2, that is chlorine. Then it forms tetrachloromethane and HCl is liberated. This is about substitution, means each substitution is very simple reaction. These are the examples for substitution reaction. Next, last we are going to learn is properties of ethanol. What is ethanol? Is it alcohol or carboxylic acid, children? Yes, good. It is an alcohol, ethanol. What is the formula? C2. What is the formula, children? C2H5OH. Yes, good. How do you write this structure? Means it. This is the structure of ethanol. Next, we learn about general properties of ethanol. Commonly called alcohol, liquid, or generally it is a liquid at a room temperature. Next, the active ingredient in all alcoholic drinks. All beverages, it is an active ingredient. Soluble in water in all proportions. Good solvent used in medicines such as tinctures, iodine solution, cough syrups and many tonics. They are the general properties of ethanol. Next, general properties of ethanoic acid. What is the formula? Is it alcohol or ketone? No, it is a carboxylic acid. Good. If you know the functional groups, then definitely we will write the structure. What is the structure? Ethanoic acid. Structure. This is the structure of ethanoic acid. Ethanoic acid is also acetic acid, belongs to group of acids called carboxylic acids. Next, carboxylic acids are generally weak acid because why they are weak acid? Their H plus ion does not completely dissolve or it does not completely dissociates. So they are generally weak acids. Glacial acetic acid, another name of ethanoic acid, but pure ethanoic acid that melts at 290 Kelvin, hence it freezes during winter. That is glacial acetic acid. Next, vinegar, generally we use in our kitchen. Most of the mothers will use this vinegar. It is used in the preservative in pickles. Next, for today's class, we have learnt about chemical properties of carbon. Let us quickly recap this. First, we have learnt about combustion reaction, and there are two types of combustion reaction, that is completely combustion reaction and incompletely combustion reaction. Second reaction we have learnt about what? Can anybody tell? Yes, what? Oxidation. We know what is oxidation definition, and here oxidation means alcohols are converted into what? Carboxylic acids. Next, in the presence of what? Acidified K2Cr2O7 or alkali KMNO4. Next, we have learned about what? Addition reactions. At last, we have learned about substitution reactions, and we went through general properties of ethanol and ethanoic acid. For today's class, let us have some assignments. Alkanes undergo only substitution reaction, but alkenes and alkynes undergo both substitution and addition reaction. Why? Very important. You have to think this question. Very important. It's very important question. Please think. Go again detail. Go back to the video. You'll learn what is first you write what is substitution, what is addition. Then it is easily to answer this question. Next, how do you convert ethanol into ethanoic acid? Compare the physical properties of ethanol and ethanoic acid. Next, what is hydrogenation? Thank you, children, for today's class. Let us revise these topics today only. We will meet next class. Sai Ram. Thank you very much.